Okay, chapter 9 homework 23, sorry. Ask you specify which compound in the following pairs of ionic compound has a higher lattice energy. KCl or magnesium oxide. Okay, for the lattice energy, we need to compare two factors. One is a charge, the other is a size, because lattice energy equals to Q1 times Q2 R squared. So Q in the numerator, while R, the radius of the R in denominator. So we compare these two compounds. Clearly, potassium chloride is +1, -1. And magnesium +2, oxide is -2. So the charge for magnesium oxide is much greater than potassium chloride. It's 4 times higher, right? 2 times 2 is 4. And the size, chloride compared with the potassium ion compared with magnesium ion, and the chloride compared with oxide. So chloride is greater than oxide. Potassium also greater than magnesium because potassium is next period compared with magnesium, and chloride compared with oxide also next period, right? So potassium period 3, magnesium period 2, and chloride period 3, oxide period 2. So both cut iron and on iron tell you magnesium and oxide size is smaller than potassium and chloride. So overall, their size together is R plus and R minus together is smaller. So smaller size tell you this is a greater lattice energy, and greater charge also tell you greater lattice energy. So both charge and size tells you magnesium oxide will have greater lattice energy than potassium chloride. Second one is a lithium fluoride, LiF, or LiBr. So this time, clearly, Li, these two cut down exactly the same. +1 charge. Fluoride -1, bromide also -1, right? Charge exactly the same for these two compounds, both +1, -1. Now lithium size also same cut down. So only difference is the fluoride and the bromide. Fluoride period 2, bromide period 4. So as we move on, this size is larger. Size larger, then lattice energy smaller. So clearly, this have greater lattice energy. Magnesium nitride or sodium chloride. Compare with the charge, magnesium +2, sodium only +1, nitride -3, chloride -1. So clearly charge, this is greater. This is 2 times 3. And this is 2, this is 1 times 1. Of course, any compound always positive charge the cut iron, negative charge the on iron. So don't care about the negative. We consider the absolute value. So 2 times 3 is 6, and 1 times 1 is 1. So this is much greater. Compare size. Magnesium size is smaller than sodium iron. And nitride size also smaller than chloride iron, because nitride from period 2 and chloride from period 3. So this is greater in size. This is also greater in size. Right? So both charge and size tell you magnesium nitride will have greater lattice energy. If any two compounds tell you charge A greater and the size A also greater, so greater size tell you smaller lattice energy, but the greater charge tell you greater lattice energy. Then choose one charge. Charge is critical because charge is from 1 to 2 or from 1 to 3. So either doubled or tripled or even 4 times higher. And the size is only gradually smaller or greater. So charge is more important than size in determining the lattice energy. Okay. Okay, 29. Question 29. Ask you how many lone pairs are on the underlined atoms in this compound. So first compound is hydrogen bromide. Underlined is bromide. How many lone pairs? So we need to write Lewis structure. So there is a single bond between hydrogen and bromine. So bromine initially 7 valence electron from group 7, 8, right? To form a single bond, need to use 1, and the hydrogen also use 1. So hydrogen initially only 1 electron, only 1 valence electron, so group 1A. So no lone pair. And bromine initially 7 valence electron, use 1 to form the single bond, left over 6. 6 is 3 lone pairs. Hydrogen sulfide. Underlined is sulfide. So hydrogen sulfide, Lewis structure is single bond between hydrogen and sulfur. Two single bond between hydrogen and sulfur. Sulfur initially 6 valence electron. To form a single bond, need to use 1. So form another single bond, use another 1. So left over only 4. So this is 2 lone pairs. In sulfur. And last one is methane. Underlined is carbon. So methane, the Lewis structure looks like this. 4 carbon hydrogen single bond. Carbon initially valence electrons 4, but you need 1 to form any single bond. So use 1 for this single bond, use for other single bond, use 1 for this single bond, use 1 for this single bond. So all 4 valence electrons be used to form this 4 single bond. So no lone pair, 0. 38. As you classify these bonds are ionic, polar covalent, or covalent, and give you reason. Okay. Silicon-silicon bond in this molecular. So clearly silicon-silicon bond. This is a bond between two exactly the same atom from same element. So definitely covalent bond between two exactly the same atom from same element. So electronegativity, no difference. So covalent bond. B. Silicon chloride bond. Silicon chloride bond in this molecular. So this time also use silicon chloride bond. Silicon chloride, total 6 silicon chloride, right? 1, 2, 3, 4, 5, 6. So this clearly polar covalent bond because these two atoms from two different elements. And this metalloid and this non-metal. So they are different, but not far away from each other. So polar covalent bond. The rule is if you use electronegativity from the textbook provided you, so during the quiz or test, may provide you electronegativity number. So their difference is less than 2. So this will be a polar covalent bond. And these two exactly the same, so no difference, of course, covalent bond. The calcium fluoride bond in calcium fluoride. So this is a calcium fluoride, right? So this bond, calcium group 2A, very this is active metal, and fluoride is a very active non-metal. So they are far away from the periodic table. Active metal bind with active non-metal, this ionic bond. If you want to use electronegativity, you will find this is a pretty small number. Fluoride is a very good, large number. The highest is 4, right? Their difference is greater than 2. This also tells you this is ionic bond. So for me, I even don't need to use electronegativity number. I can judge this is ionic bond because this is active metal. This is very active non-metal, so ionic bond. So metal lose electron, non-metal gain electron. And these two, metalloid and non-metal, they have big difference, but not as big as 2. So this is a polar covalent bond. And these two exactly the same, no difference. The electronegativity exactly the same. So this is a covalent bond. Okay, one more. Show you lowest structure. Let's say 42. Here you one. Ammonium iron. So If this is NH3, then Lewis structure looks like this. Okay? Right. Nitrogen initially 5 valence electron. Use 1 to form each single bond. Then 3 be used to form 3 single bond. Then 1 lone pair left. Now it's NH4 plus, so NH4 plus. So this find 1 more hydrogen together carry positive 1 charge. Okay.